here's an example of how to put this all together. Say quadrilateral ABCD has vertices A at 0, -1, B at 6, 1, C at 8, 7, and D at 2, 5. I would like to know what type of quadrilateral ABCD is, and then prove that it actually is that quadrilateral. So I have several options. It could either be an irregular quadrilateral, meaning nothing special, only that it has 4 sides. It could be a trapezoid, meaning it has one set of parallel sides, only one set. A parallelogram has 2 sets of parallel sides. A rhombus is a parallelogram that has all congruent sides. A square is a parallelogram with all congruent sides and all right angles. And a rectangle is a parallelogram with all right angles, but not all sides are congruent. So, in order to get a handle on this, what I like to do first is to look at all of the slopes of each side. If only one set of sides is parallel, then I know I'm going to have a trapezoid. If 2 sets of sides are parallel, then I know it's a parallelogram. So I'm going to have to find the slope of each of these lines. To do that, I need to look at all of the change in y's and change in x's. Then I can get each of my slopes. So the slope of line AB, the line that goes through points A and B, would be change in y, 2, over change in x, 6, which reduces to 1/3. For the slope of the line that goes through BC, would be change in y, 6, over change in x, 2, which is 3. For CD, change in y, -2, over change in x, -6, which is 1/3. And change in y for AD is -6, and change in x is -2, which gives me 3. Looking at these slopes, I can see that AB is parallel to CD, since they have the same slope, and I can see that line BC is parallel to line AD. So that is the conclusion I'm going to write. Since slopes are equivalent, AB must be parallel to CD, and BC must be parallel to AD. Since ABCD, quadrilateral ABCD, has 2 sets of parallel sides, it is a parallelogram. I'm making that conclusion from the definition of parallelogram. A quadrilateral with 2 sets of parallel sides is by definition a parallelogram. All of the work that I've shown to show this is my slopes and then my conclusion from that information. But I'm not done, because there are several types of special parallelograms. So all I've done is eliminate irregular quadrilateral, because I have at least one set of parallel sides. I've eliminated trapezoid, because in addition to just one set of parallel sides, I have 2. So I'm left with, it could either be a parallelogram, a rhombus, a square, or a rectangle. Now I'm going to make a couple of other observations. Since the slope of AB and CD and AB and BC are not negative reciprocals, they cannot be perpendicular. So let me make that as a conclusion. Since the slope of AB and the slope of BC are not negative reciprocals, it is not a square or a rectangle. The reason I can make that conclusion is because a square or a rectangle would have right angles in those corners. Since these are not negative reciprocals, they are not perpendicular, therefore they do not need to form a right angle. So I can cross off square and I can cross off rectangle. But I still have to show whether or not it is a rhombus. So I'm going to look at that slightly more in depth. To show something's a rhombus, you may or may not remember this theorem. If 2 consecutive sides of a parallelogram are congruent, then it is a rhombus. So I'm going to look at the lengths of 2 consecutive sides, namely AB and BC. To do that, I need to use distance formula for length. I'm going to plug in the change in x squared and the change in y squared. The change in x is 6, and the change in y is 2. Put that all together, I get the square root of 36 plus 4, which is the square root of 40, which does reduce. I have 8 times 5, give me 40, so this will be, 4 times 10, so this is the square root of 4 times the square root of 10, which equals 2 square root of 10. That would be the length of AB, so I'm going to simplify that out. AB is 2 rad 10. And then I'm going to look at the length of BC. BC is this, again, distance formula, square root of 6 squared plus 2 squared, change in y, change in x squared, equals the square root of 36 plus 4, which is 40, which again reduces to 2 square root of 10. So I've just showed that the length of AB and the length of BC are exactly the same. That means that I have 2 sets of consecutive sides being congruent. Well, I've already showed that this shape is a parallelogram, and now I've showed that 2 sets of consecutive sides are congruent, so the conclusion I can make from this information is that, therefore, ABCD is a rhombus. This is something that I could confirm by sketching the graph. If I actually plot all these points, here's some of this information out of the way. If I plot all these points, I don't really have a good place to put it, but you can actually see that this does form a rhombus. That's something that you could do to check your answers, or if you were lost at the beginning and weren't sure how to proceed, you could always plot it, but then you still have to prove it. The proof for all this information is given to me. This entire page of work would be all of the work I need to show. I showed all of my work for computing the slopes. Then I made my conclusion based on the slopes. Then I made an observation in order to simplify things for me, that it couldn't be some shapes. It couldn't be a rectangle or a square because I don't have negative reciprocals. And then it remained to be shown that I had a rhombus. So I looked at the lengths of 2 consecutive sides and made my conclusion from these lengths. All of this information would be necessary for a solution. As long as it is on your page, I will accept it.